Here we're looking at assignment 81, up the staircase. This is a diagram that describes phase changes. So you may recognize that water comes in three different phases. There's H2O solid, that we know as ice. There's H2O liquid, which you would probably just call water. And then there's H2O gas, which you would call water vapor. The temperature has a large effect on which phase the H2O will be in. So this graph, you have to imagine, first look at the axes. There's energy added, joules. And then there's temperature over here, temperature. So let's imagine now you have this a beaker of water. I recommend you draw this picture. And it'll start as ice. So let's start it as ice. So it's cold, solid, and we'll have some way of heating up the ice. So maybe an electric heater that will add energy here to the ice, and we'll be able to monitor the temperature as the heating coil adds energy to the ice. Here's the first question that asks you to add labels to your diagram. Label sections A, C, and E on the graph above. A, C, and E. Solid, liquid, gas. So for this, the sector in A is cold. Notice that the temperature here is 0 degrees Celsius, and A is at a temperature less than 0 degrees Celsius. So this is below the freezing point of water. This will be a solid state of water. The second segment is C, and you can see C is in the middle here, and it is between 0 and 100 degrees Celsius, and that is the temperature range at which you would have liquid H2O. Whereas E, way up here, is a high temperature. This is above the boiling point of water, and that's the temperature at which you would have gas. So here's solid, liquid, gas on the diagram. So now I want you to look at number 2. Here in this box are some important notes which should make sense to you. Temperature measures the kinetic energy of molecules, whereas bonding state, determines potential energy of the molecules. So with those definitions, I want you to try number 2. Pause the tape. I'll tell you the answers in a few seconds. Okay, so it's asking you to use labels A through E to match these descriptions. When kinetic energy increases, increasing kinetic energy, that should mean that the temperature rises. That's how kinetic energy is measured. So if we say, where are gas molecules rising in temperature, that's letter E on the graph above. If we say, where are bonds breaking? There are 2 places that occurs in the graph, 2 places. One is at the solid to liquid transition. That's letter B. One is at the liquid to gas transition. That's also bonds are breaking. The type of bonds that are breaking are your hydrogen bonds. You'll recall that the hydrogen bond is a friendship bond, not a covalent bond. So we're talking about something like this being important to holding the molecules to each other, and therefore determining the state of matter, whether it's solid, liquid, or gas. So B and D are phase transitions. That's where bonds are breaking. Where are solid molecules getting warmer? That's clearly A, where the temperature is rising. And gaining potential energy is whenever the bonds break. So that is in B and also in D. Bonds breaking up here, bonds breaking, increase the potential energy. Okay, take a look at number 3. This term, heat of fusion, has a special abbreviation. This delta H is the heat, and FUS stands for fusion. Fusion in this case means melting. 80 calories per gram. This means it takes 80 calories, you know what a calorie is, to melt 1 gram of ice without any change in temperature. This is hard for people to understand. How can you melt ice without changing its temperature? But if you look at our graph here, look at the graph. Where does solid become liquid without changing temperature? That's this part B here, right? That's B. Here the temperature is 0 degrees Celsius, and we're going from solid to liquid. And so there is a time when all the energy from the heating element will be going into breaking bonds rather than raising the temperature. That's the phase transition. That's B. Now you try to do the math for questions 3B and 3C here. Try to do the math on your own. I'll show you the answer after you've paused the tape. Here's the answer you should have. H2O is H, which is 1, plus H, which is 1, plus O, which is 16. It's 18 grams per mole. We can use that in C to say, well, 1 mole of H2O, 18 grams. And the information here says 80 calories per gram is required to melt ice. 80 calories per 1 gram of H2O. That's the heat of fusion. And then we multiply those together, and you get 1440 calories. So this is, let's label it actually, needed to melt 1 mole H2O solid, and particularly this is at 0 degrees C. So it's a lot of energy needed just to melt the ice. Need to pause the video to redo D and E, do so now. I'll show you the answers after you've figured it out. Okay, so we have 1440 calories. I'll do dimensional analysis. Proportion will get you the same answer. It's 4.18 joules per calorie. And so then I get out my trusty calculator and I find the answer to be 6,019 joules, which I'll round to 6,020 joules. That's 3 significant digits. And it says convert that to kilojoules. Well, if I make that a whole number for convenience, that's 6.0 kilojoules. There's my answer. So here I can write 6,020 joules, which is equivalent to 6.0 kilojoules, are needed to melt 1 mole of H2O solid. And that's a nice conversion factor now. I've made a new one, which I can use in E. 75 grams of ice. I'll do it this way. That's H2O, right? Ice is H2O. 1 mole is 18 grams of H2O. I've just found that it takes 6.0 kilojoules for each mole of H2O. And so this is fairly simple dimensional analysis. 75 times 6 divided by 18 equals 25 kilojoules needed. And that's to melt 75 grams of ice.